Hello everybody, this is Paddy, and in this tutorial I will show you how to create a sunbath in Ladybug tool in Grasshopper. So without further additions, let's dive into Rhino and Grasshopper. Hello again. As you see here guys, we are in Rhino and Grasshopper, and I have created this sunbath for you to show you how we can create the sunbath in order to perform many analysis such as solar radiation analysis and much more for your buildings in the design stage. I have created this by using the Ladybug tool. So how we can do that? Let's do together. I will delete all of these in order to start from the scratch. Okay. First of all, you have to know that you have to bring the ladybug icon and drag it in the canvas. This is very important because we have to make sure that ladybug is working. We can check that by putting a panel and see that ladybug is flying. Maybe I need here to put a bifocal. This will help that you can know the names of the components when I am working. Now the first step is to bring an EBW file, which is Energy Plus Weather Data file. I have options here of download or import or open an EBW weather data. So I am going to show you how to download if you don't have one. I will drag this Ladybug download EBW weather file components in the canvas, and in order to download we have to assign a boolean toggle here. Once I click to true, it will take me to a website which is ladybug.tools/EBW map. You can check where in the world you want to download. I am going to download for Ankara city, which is the capital of Turkey. So I am going to go to this blue sign and download the EBW file. Once done, I can go and unzip it, and then we have the path of our EBW file. I will go back here, and then I am going to import EBW file. And once I bring the Ladybug import EBW file, I can now go here and bring a file path and connect it to the EBW file. Right click and select one existing, go to the download file and select it, and now it works. Now the second step is to go to Ladybug tool, and I am going to go to visualize weather data, and I will bring Ladybug sunbath and put it here. As you see, we have information here as inputs, as a location and the analysis period and much more. We need to connect the location here to the location in the sun bath, and once we connect it, we can go back to Rhino and see if we have a sun bath. Maybe the scale of the sun bath is too big. Yes, we have here the sun bath. Let's check much more and see what here we have a sun here. The reason that the sun is here is that the Ladybug giving a default for the hour and day and the month, and we can read here that the default of the hour is 12, and the default of the day is 21, and the default of the month is 12, which means December. So you can now give maybe any hour any day and any month in the year. Let's try that. Let's give, for example, hour from 1 or from 0 to 24 hour, and connect it to the day. Sorry, for the hour. Maybe we can disconnect and to the hour. And as you see here, once I connect that, it will not work. Why? Because in 0 hour we don't have any sun. So Ladybug understand that it can, maybe if we want to 3, 4 also there is no sun, 6 there is no sun, but in 8 we have a sun here. Also maybe if we came to 7, why there is in 6 and 7 no sun? Because the month is December. Maybe if we put April, for example, yes, it works at 7 o'clock in the morning. And as you see, once I move that, the sun will move all over the day here. So instead of do that, if you don't want that, maybe you can use an analysis period. And an important thing to tell you guys that we have, if you notice that we have dashes here. If the dash is after the word, this means that you can use it or not. But for location, for example, it is before. This means that it is a must to connect something and information to this input, which is location. Okay, so let's do assign an analysis period to this tutorial. To assign analysis period, maybe I can go to analyze in the Ladybug tool, and the first component is Ladybug analysis period. I will drag it here and then connect the analysis period in this component to the analysis period in the sunbath component. Maybe it will take some time because the default of the analysis period is all over the year from January to December, and this will be reflected directly to the graph of the sunbath. So we will wait just a bit in order to see the result of this analysis period connection. And yes, we have done. As you see, we have now the sun all over the year because this is the default. But also you can give any month and any day and any hour from to month, from to day, and from hour to hour. Okay, another thing to show you is the sun bath scale. If your building is a little small or something like that and you want to control the scale of the sun, you can control that from the sun bath scale or the sun scale. Maybe we need to make it smaller. If we want to make it smaller, we can do that, for example, by assign a number slider. Maybe I can put 0.1 to 0.8, for example, and now maybe I can connect this to sunbath scale, and once I connected it, it will be smaller. Also, this will be taking time because maybe my PC is slightly slow, but it will give us the result at the end. And yes, we are done here. As you see, the sunbath and the scale of our sunbath will be smaller in this moment. Okay, another thing to show you that if you are not interested on the color of the compass or these curves of the sun, you can change them from the output here. For example, we have here sunbath curves and compass curve. I am going here to use a custom preview component, and once I bring it, we can connect the sunbath and the compass curve, but make sure here to press the shift key. And also to change the material I have to use something that is called color swatch. Here maybe I can click here and change the color to maybe black or any color you want, accept, and then connect this to the material, and as you see it will be changed to black. The final thing that I have to show you that we have here annual hourly data, and we can connect any data from the EPW file to this icon and it will work. This means that I can make the sun bath according to or based to dry bulb temperature all over the year, for example. So if I connect this to annual hourly data, you can see that the sun will be colored according to the temperature all over the year. And yes, we are done now. As you see, the sun bath and the sun all over the year were colored according to the dew bulb temperature. Yes guys, this is enough for this today tutorial. I wish that you are interested in it. Please like and share this video. In the next video I will show you how to perform a solar radiation analysis in Ladybug. Goodbye. Hello everybody, this is Fadi, and in this tutorial I will show you how to perform an energy simulation in Ladybug and Grasshopper. So I collected these graphs from the energy simulation of these maybe spaces. We have here 2 rooms, maybe office buildings, office spaces, and 1 corridor here, and I have created these simulations or graphs about the energy use in these spaces. So how we can do that? Let's do that together. So I am here in Rhino, and as you see I have here these 2 geometries with a corridor, and I will go to Grasshopper and start from the scratch. But before we getting started, I would like to ask you to subscribe the channel and like the videos if you are interested in more tutorials in this kinds. First of all, I have to go to Ladybug and bring the Ladybug component and put it in the canvas. Also I have to bring the honeybee and put it here in the canvas. Let's now give the bifocal here to have the names. This will facilitate to you. Okay, now first of all I have to double click and write geometry, and let's copy that, one for the offices and one for the corridor. I will go for example here for multiple and choose set multiple geometry for the corridors, and if you want to change that to maybe the name to office, okay, you can see that it changed to the office. And for the second one I choose the corridor. Let's also change that to corridor. Okay, now we have to bring something that's called mass to zone in honeybee and connect the offices zones geometry and the corridor, but we have to click shift here, and as you see, if I put a panel here, you can see that I have null because I didn't create the honeybee zone. So I have to now bring it Boolean toggle and connect it here, and turn it to true. And as you see here, I have 3 closed brief, 2 offices and 1 corridor. So let's move on. Now we have, as you see, let's hide these geometries, and grasshopper now know that these are honeybee zones. Now we have to solve the adjacent between them to let grasshopper know that where is the walls, where is the interior walls, the ground floors, the roof, etc. So I have to bring this honeybee solve adjacent and connect these to the solve adjacent. Let's also make sure about what we get. Also we have to copy this and also run the adjacent to find the adjacent between them. Maybe, yes, we have now 3 preps. Okay, now we solve the adjacent between the zones. We can also now apply windows maybe to this elevation, which is a south elevation. So how we can do that? I will bring component that is called glazing based on ratio and connect the honeybee zones to that. For the glazing ratio, I will bring another component that is called glazing parameter list and connect it to the glazing ratio. I need to adjust now, assign now parameter or number slider of the south elevation parameter. I will go with 0.3 for the glazing ratio, and now also we have to run it by assign a toggle boolean here. Once I hit to true, as you see, I have windows on the south elevation of these offices. Okay, now maybe we can also, if you want to visualize them, we can use decompose, honeybee decompose based on type. Let's choose walls, roofs, floors or ground floors, and windows to visualize them in such way. I will go to custom, preview. Maybe I need also swatch. Let's give them white. Okay, white. For the material, I will bring the walls, the roofs, and click shift here also. And for the floors or the ground floor also, I will take them. Maybe we need to preview this and also this. Maybe also the geometry. Click preview off. As you see, I have a color here. Maybe I need to assign some material to window. Maybe I can copy this, right click and disconnect all. I will give the window maybe something like this color and connect the windows to the geometry. So I have these. Now that this is just for visualization. Now we need to bring the energy plus, run energy plus simulation. So I will write here run energy plus simulation, this component. But in this component, let's see what we need. We need EBW file and we need the honeybee zones. So I will connect now the honeybee zones to the honeybee zones in the energy plus simulation. I need EBW file, so I will double click and have a file path here. Right click and set one existing. Maybe I can go with some of EBW file here for Antalya city and connect it to the EBW file here. Okay, as you see, now I need also maybe the simulation output. So I will go to find the simulation output. Here I have honeybee simulation output. It's not that. Let's write output. Yes, this one, honeybee generate energy plus output. And in this tutorial we need just to see the zone energy use. Maybe you can also have the zone comfort matrix or anything you want. Maybe in next videos we can also explain how to make a thermal comfort simulation, but in this tutorial I will have to go with the zone energy. I will connect this boolean toggle to the zone energy use, double click, and then connect the simulation output to the simulation output in the energy plus. Maybe we are ready now, but we have also to run this energy simulation. So I want to give here the run energy plus and also the write IDF in order to have the results in your file. And once I click to true, it will make some warming up to make the simulation for the spaces that we assigned. Once finished, you can see that there is no results here or in the Rhino. So how we can visualize these results? First of all, we have to read the result file address. So I will go here and write read, or maybe we can write result to have the correct one. We need honeybee read energy plus, honeybee read energy plus results, where we can do maybe this one. No, results, I think this one. Yes, and we have now to connect the file address, result file address, to the result file address here. It will take some time to read the results. So as you see, it will be just include the energy use in these spaces. So I have total thermal load, total load balance, cooling, heating loads, electrical light, and electrical equipment, because they are related to the energy used in the spaces. So how we can visualize or have something of that? Let's do maybe a panel here for the total thermal loads. And as you see, I have now a list of the let's say the total thermal results all over the year, and this is the default all over the year, because here we have analysis period, and the default is all an optional analysis period. You can assign that from the ladybug. So if you want to assign analysis period, you can come here to ladybug analysis period and assign from month to month, from day to day, from hour to hour, but the default is about all the entire year. So now how we can visualize these data? For example, if I want to know how what is the cooling and heating loads in these offices, we can now go to visualize and ladybug 3D chart. I will put it here. Maybe we can also give, for example, the heating or cooling. Let's take the cooling loads and connect it to the ladybug 3D chart. As you see, it will take maybe some time, but as the result, it will give you the graphs for the three spaces, for example the offices and also the corridor. We have here the kilowatt all over the year from January to December in the selected area that we put. So now this is parametric, So if I change, for example, to the total thermal loads, it will be changed automatically for the graphs. As you see here. Also, you can maybe change these let's say red lines by coming here for the graph mesh or graph curves. You can use custom preview for the mesh, for the curves, and you can give him a swatch color. Let's say that we need a black. Okay, as you see, it will be turned on. And now if you want these graphs to be out or exported to as a JPEG or PDF, you can go to File, Print, and you can play now with the image size, maybe to have your graphs out of this as a PNG or TIFF or JPEG, or you can choose Rhino PDF. But if you want to choose Rhino PDF, you have now to maybe bake these graphs. As you see, it will be like that, and then print it. That's all for today. I wish that this is the basics of energy simulation in Ladybug. This is a quick tutorial. I wish that you are interested in it, and please subscribe the channel for more tutorials. Goodbye.
What's going on, guys? This is Fadi from Parametric BIM, and in this tutorial I will show you how to create a cool daylight analysis such as these photos. In fact, this is the simplest way to ensure that you have a sufficient daylight amount in your design space in the early stages of your design process. So without further additions, let's dive into Rhino and Grasshopper. As you see here, guys, I have a sample model. Let's say a sample of office space. It contains of some lab tables that are arranged in a certain way. The model also have a window on the south facade and a door, and also the model contains from some components that are arranged in a layers such as the walls, roof, ceiling, glassing, and so on. So we can control these by turning on and off these layers, as you see. But we have now to create a geometry or analytical geometry to be determined by Grasshopper, Honeybee, and Ladybug to perform this simulation. So I am going now to draw a geometry. And now we have this geometry. Let's move to Grasshopper canvas. In the first step, I will start here by using geometry component in Grasshopper. So maybe I need to turn off the layers, and let's leave the furniture and window layer. In the second step, I will convert this geometry to mass using a component that is called honeybee mass to zone. You can double click and search for it, or simply you can bring it on from honeybee toolbar. Yes, here we go. We have now to connect the geometry to zone masses, and do not forget to create honeybee zones by double click and search for Boolean toggle. We can connect and turn it on to true. Let's check now by creating panel by writing double slash, or you can simply go to the parameter tab in Grasshopper and drag it to the canvas. As you see, it is a closed brief. This means that we are in the right way. Let's move on. The third step is to create the window to the geometry, because this window is a Rhino component and we have to have a window in our geometry. And as you see here, we have one window on the south elevation of the office space model, and this window have a height of 1.5 meter, and the cell height from the ground floor is 1 meter. An important thing here to be considered is the glazing ratio, because it is important in the daylight factor analysis. And by dividing the area of the window by the area of the wall, which is called window to wall ratio, the glazing ratio is equal to 0.5 in our case. So let's see how to do that in Grasshopper. In order to create windows to our geometry, I am going to use a component in Honeybee tool that is called Honeybee glazing based on ratio. Let's connect the honeybee zones to honeybee objects in the glazing ratio component. Now we have to assign a glazing ratio, so I am going to create a number slider with 0.5 value and connect it to the glazing ratio. Also, do not forget here to run it by a true Boolean toggle. And assign the glazing ratio, which is 0.5, to south glazing parameter in this component. As we noticed, the windows were created on all of the office space sides, and this is actually not true. So instead of one value of a glazing ratio on all sides, I am going to use a component here in Honeybee that is called Honeybee glazing parameter list. And assign the glazing ratio, which is 0.5, to south glazing parameter in this component. As we said before, the window height is 1.5 meter and the cell height is 1 meter. So I will assign these values to the component as well. Maybe we can also control the break up window option by Boolean toggle. Now the window with its ratio is created to our geometry. Let's move on. In the fourth step, I am going to decompose the geometry element by using a component that is called honeybee decomposed based on type. The reason here that I want to take only the ground floor surface in order to simulate the daylight factor value. The fifth step is to create a grid to simulate the daylight factor. So I am going to use a component that is called honeybee generate test point. I will connect the ground floors to test geometry. And for the grid size, I will assign a value of 0.5. For the distance from base surface, I will assign 0.67. These values were recommended by lead V4 as an average of the test surfaces of daylight factor on table level surfaces, that the grid surface is below the ground surface, but this is not a big deal. We can flip the surface upward. In the next step, I will bring a component that is called honeybee daylight factor simulation. The step is to run the daylight simulation using honeybee run daylight simulation, and I will connect the results in the analysis receipt to the analysis receipt in the run component. For honeybee objects, I will go back and bring the last modified honeybee zone and connect it. We have now to run the simulation by using Boolean toggle. After running the simulation, we can notice that there is no graphical representation for the daylight factor results. Simply go to Ladybug and bring a component that is called Recolor Mesh. Connect the daylight factor value to the analysis results and go back to the generate test point component and bring the mesh and connect it. The results appeared in a graphical way. Let's turn off the preview to see the results. We can now change and play with the bounds of the parameter by using a component that is called Ladybug legend parameters. Maybe we have to play with titles. We can change the name of the analysis title and we can change the legend title as well. We can also change the grid size to less than 0.5 for more grid size and more quality. You can now turn on the building component layers for more realistic graphical representation. And yes, this is very much for this video. Thank you for watching. Please like and share this video for more daily tutorials. Have a nice day.
Hello everyone, this is Fadi again, and in this tutorial we are going to simulate the daylight illuminance for a room. As you see, I have here a room which is a patient room in a hospital, and I made an analysis for the daylight illuminance. So we have here some windows at the south facade, and here a door, and we have a patient room. So we can easily simulate the daylight illuminance after watching this video. So let's go to Grasshopper and see how we can do that. Let's first of all turn off the simulation and go to the top. So as you see here, we have a patient room. We can turn off the furniture, and then let's see how we can do the daylight illuminance. The daylight illuminance, or the useful daylight illuminance, is an output for the honeybee annual daylight component. So let's do that and understand how to do that. First of all, we have, as you know, to set up and construct our geometry. So from honeybee room, from solid, we can use a brief and assign it to our geometry in Rhino, and after that we can set the parameters of the honeybee from solid, if it is conditioned or not, or what is the program of it. So it is an hospital, and to take all the parameters of the hospitals, and then we can assign the program for it. We can also construct a window with a glass material. What's the glass material? If it is double or single. For example, here I have a double material, so I assigned a honeybee glass material with a thickness to the window construction, honeybee window construction, and then I put a gap with air with a thickness here in between, and then also the frame I give some properties for the frame, for example the width, the conductance, and you can also give some properties for the outside projection, the thermal absorption, the visual absorption, the solar absorption, and so on. After that we can easily give it to the energy plus construction for the honeybee aperture component. So this is the aperture for the windows, and then we can also connect it to the honeybee at the surface component, which contains the geometry, our geometry from here, the room, and then also we can have the subsurfaces that contain the windows and the construction of the windows as we talked, and the door also. We have to assign it. If there is another construction, energy plus construction or radiance modifiers, we can also give it to here. This is the basics. So in next videos we can also talk about this. Then we came to the solve the adjacencies for the honeybee model. This is if we have more than one room. So here we have a room, so it is not important. For that we can connect directly from here to the model visualization, or directly to the honeybee model. From the honeybee model here you can see that we assign a grid, and we assign also after the grid we can also have the grid from here that contain the ladybug generate point grid and the honeybee sensory grid. We can assign a grid. For example, we have a dimension here for the grid which is 0.5 and 0 from the surface, because I assigned a geometry for the grid, so it is not important to give a distance from the floor or so on. And then we assign all of that to the daylight, annual daylight, honeybee annual daylight. But this component also need the WAE from ABW file, so we need a ABW file. We can easily download the ABW file from the internet, and this is the website, which is the climate1building.org. You can download this EBW file, and also we have to assign the hour of the year. So this came from analysis period. Here it is an output for the analysis period, so you can bring up the ladybug analysis period and then assign it to the hour of the year, and then the WEA is connected with the WEA with the annual daylight, and the model we connect it here, and then we have to run the simulation. After running the simulation, we can also to see the results. We have to bring the data that is the output of the simulation, and then we have to make the average or not. It is not important, but to take all the average for the useful daylight illuminance or the useful daylight lower than useful daylight illuminance and the above the useful daylight illuminance. And this data will be connected to ladybug spatial heat map to see the results. Also here we have the ladybug legend parameter to assign, for example, colors if you are not interested in the colors that ladybug give, which is the ladybug color range, and we will talk about this later. But let's run now the simulation and see the result. When we run the simulation, this window will appear to run the simulation and to see the result according to the analysis period that we have assigned, and also to the model parameters that we have assigned. So easily you can get the results of the daylight, annual daylight, that contain daylight factor and other parameters such as useful daylight illuminance and the lower or the below useful daylight illuminance and the above of daylight illuminance. Let's speed up this process and see the result. So yes, we are done here. As you see, we have the result here of the useful daylight illuminance according to the analysis period that we have assigned. Maybe this is in summer period. So this is the daylight illuminance. As you see here, it is a percentage of how much this grid have a useful daylight illuminance between 200 and 100 and 2000 lux through over the analysis period, which is from here from June to September. Yes, and the hour from 7 o'clock to 7 p.m. to 5 p.m. 7 a.m. to 5 p.m. So this is the output of the spatial heat map. So if I turn it off, it will be gone. And here, if I connect this to the data, you can see this is the below of useful daylight illuminance. This means that most of the room has 74 or 75% that are lower the useful daylight illuminance, maybe because the windows are let's say small or something like that. And if I connect the useful daylight illuminance up, you can see that these are the up of the daylight illuminance, which is similarly good because it is below 1% or something like that. And here are the areas around the windows that have a much more useful daylight illuminance, which is above useful daylight illuminance. We can easily connect this one, which is the ladybug color range, instead of these colors, so we can get some colors here, another styles of colors. For example, 1 0. When we move up, we can get more than styles of colors, but for useful daylight illuminance I prefer my colors. So if I connect these one by one, you can see that the result will be more clear for me. So this video clarify how to simulate the useful daylight illuminance by setting up a room. Maybe in next videos we can see more than the annual daylight, such as the daylight factor and here the continuous daylight autonomy and others, for example thermal comfort and other features such as these. Thank you for watching, and if you like this kind of videos, please like, share and subscribe for more tutorials. Goodbye.